Hello everybody, welcome back. Today we're starting 4.2. We're looking at irrational numbers. We're going to identify and order irrational numbers. Alright, so let's get an understanding of what the difference between rational and irrational numbers. So a rational number is a number that can be written basically as a terminating decimal or as a fraction, where the numerator and denominator are obviously integers. And the ones that are not rational numbers, those are the ones when you do an operation on them and they are non-terminating, non-repeating decimals. So for example, like pi has no pattern. It's 3.14159 dot dot dot. So it goes on forever, even when the square root of 2. Square root of 2 is 1.41 dot dot dot. So it does not terminate, it does not repeat. That's the easiest way that I can explain to you what a rational and irrational number is. So a rational number is anything can be written as a fraction or a terminating decimal, repeating decimals as well, and not a number that's irrational or not rational has a non-terminating, non-repeating decimal. Okay, so irrational number definition is a number that cannot be written in the form m and n, where m and n are integers, and obviously n can't be 0 because then it would be, you can't divide by 0. So the decimal representation of irrational number neither terminates nor repeats, as I discussed before. So you probably heard those before. If you didn't, we're going to hear about them now. So if x is not a perfect square, then the number of the square root of x is irrational. If x is not a perfect square, perfect cube, then the cube root is irrational, and so on. All right. So we're going to classify whether the following is a rational or irrational number. So in A, there's a number of ways. So there's a number of ways you can determine this. Remember the definition. If there's a numerator and denominator and they're both integers, which is the case, numerator is 3, denominator is 5, or negative 3, 5. So we can say that negative 3/5 is rational since it is written as a quotient of integers. So basically, if you can write this as a fraction, you're good to go. All right. Another, remember the definition. If there's a decimal representation that terminates, so the decimal representation of an irrational number neither terminates or repeats. So if we took the decimal of this, we put that in a calculator, we would get negative 0.6, right? So its decimal form is negative 0.6, which terminates. Right? So those are both ways to show that it is indeed rational. Right? So the square root of 14, there's two ways you can say this. So you can say the square root 14 is irrational since 14 is not a perfect square. So you can see that above here. So that would have to be like 4, 9, 16. So anytime it's not a perfect square for the square root, then it's irrational, right? Another way you can do it is you can calculate it. So you can take this value, plug it in your calculator. So you take the square root of 14 on your calculator. And when you take the square root of 14, you get 3.741 and so and so. So it's neither repeats or terminates, so it is irrational. So there's two ways to show whether a number is rational or irrational, and there's our explanation after the two. And the last one here is the cube root of 8/27. Okay. Now this one here might be a little harder to see, but I will show you. Is rational. So at first it might look like it's irrational, but it is rational since 8/27. Since 8/27 is a perfect cube. Perfect cube. If you don't understand that, that's fine. I'm going to show you that by actually taking it and calculating it. All right. So when we take that, we take the cube root of the numerator. So the cube root of 8. I'll do this again step by step just to make sure. You might have missed it in the previous. Oh, so we take the cube root. The wrong button. Sorry. Take the cube root of the numerator and the cube root of the denominator. The cube root of 8 or the cube root of 27, and that's going to equal cube root of 8 is 2. Cube root of 27 is 3. So it is 2/3, or 0.6 repeated, or 0.6 repeated, okay, which is a repeating decimal. So again, just a little summary. The first one was rational. It can be written as a quotient of integers, so basically a fraction where the numerator and denominator are both integers, which is the case. Or you can do it, divide the two, get the decimal, it terminates, so therefore it's rational. Square root of 14 is irrational. 1, since 14 is not a perfect square. Or take the decimal, it neither repeats or terminates, so it's irrational. And the last one, a little more tricky. It is rational, since the cube root of 8 is a perfect square, and the cube root of 27 is a perfect square. So the numerator and denominator both have to be perfect squares, which they are. Or you can do the work on it. It gets you end up putting in a calculator. You get decimal 6 if you punch it in a calculator, which can be represented as 2/3. So it is a repeating decimal. Therefore, it is rational. All right. So some here A, B, and C. There's your answers right here in the red. Rational, irrational, rational. Work them out. Give your explanation. So together, the rational numbers and irrational numbers form a set of what's called the real number system. This diagram shows how in the real number system. So we have the natural numbers. All right. So the natural numbers, as you guys are aware, maybe this will be a good little reference to make sure we get an understanding of that. Okay. So we got our natural numbers. So I'll write them down. So this Venn diagram helps us see the numbers. So the natural numbers are included in the whole numbers because natural numbers are 1, 2, 3, 4, 5, and so on. Then we have a whole number system, as you guys are aware. So the whole numbers, the only difference between natural numbers and whole numbers is we include 0, 1, 2, 3, 4. So that's what the difference between whole numbers and natural. So all numbers are included in whole numbers. See the Venn diagram. Next we have is the integers. So the integers include all the whole numbers in the negatives in 0. So it's dot dot dot, -3, -2. So -3, -2, -1. Just doing this because I'm going to run out of room. 0, 1, 2, and so on. Okay, and it goes on. All right. So and that's the integers. Sorry, the integers are okay. So it's negative. Basically to negative infinity to positive infinity, positive and negative numbers, right? No decimals. Okay, and then we have the rational numbers. All right, and so integer include there, so that includes like any of those fractions, any of those repeating decimals, any of those perfect squares, perfect cubes, etc. All right, and these all fall under the rational numbers, and then irrational numbers are ones that can't be written as that, right? So there you are. All right. So just to remember though what those were, rational numbers, we have the definition that was above. Anything written as a fraction or as a terminating decimal or repeating decimal. Okay. And irrational numbers are numbers that can't be written as terminating or repeating, right? There you go. So let's do example 2. We'll look at example 2, and it says order the irrational numbers on a number line. So what I would do is I would change all these into a decimal first. Okay? So what you want to do before we place these on a number line, what we're going to do is we're going to work these out on our calculator. So first thing we do is we're going to find the cube root, 13. We know that the cube root of 8 is 2, and the cube root of 27 is 3, so we know this is going to be a little closer to the 2 decimal something, so it's 2.351. Okay. The square root of 18, we know the square root of 16 is 4, so the square root of 18 is going to be 4 and a bit, and it's 4.242, right? That just means there's non-terminating, non-repeating. This is equal to exactly 3. The fourth root of 27, we know the fourth root of 16 is 2, so it's going to be 2 and a little bit. 2.279 and a bit, and then the cube root of -5, you get negative 1.709 and a bit. So once you have the decimals, then you can place them on the number line. So when we mark these on a number line, this is what a number line looks like. I stole that from the textbook. It's the root the cube root of -5 is just a little bit more than -2 because it's -1.709. The square root of 18 was 4 and a little bit, so this is 4 and 5, so it's a little more than 5. That was bang on 3, the square root of 9. So square root of 9 is right at 3. And the fourth root, remember we put the original values in. We only use the decimals to show us. So when you're placing the these irrational numbers on a number line, you have to put the original value back in. And same when you're ordering them from least to greatest. All right. So in order from least to greatest, it would be the cube root there, and then the next one was the fourth root of 27. Right, and then after that it was the cube root of 13, and then after that it was the square root of 9, and then the last one is the biggest value, which was the square root of 18. Okay, so we've ordered these numbers from least to greatest. There they are on the number line and right there. So there's some check your understanding questions. You do the same thing here. I provided you with a number line. The answer's at the bottom there for you. So there's homework involved. You can look at the homework questions, page 211, 3, 4, 5, 7, 11, 12, 14, 15, 17 through 19. There's your answers for the check your understanding. So that's it for 4.2, and we'll see you again when we start mixed and entire radicals in 4.3. Thank you, everybody, and we'll talk again soon.